Good afternoon, everybody. Thank you so much for making time and joining the Okta session today. Today's topic we have on Zero Trust, secure access for everyone, everywhere. We have Max Fon, who is the head of value consulting EMEA, and he'll be the speaker today for our session. Thank you, Max, for making time, and thanks for hosting the session for us. You can begin.
Thanks. So hopefully you'll get the video, as in the webcam, whilst I begin this speech. So we'll hope that figures itself out. So firstly, good afternoon all. By way of introduction, my name is Max Fawn. As you've just heard, I lead Okta's European Value Consulting practice. Actually, it's EMEA, so it picks up your region as well. Think of this as an in-house management consultancy or a systems integrator advisory. So we're staffed with the people that you would expect from those big name consultancies. And hopefully that's all I'll be saying about myself or about Okta. I'm very keen to talk about zero trust and security and not to plug my product or any specific product. And on that note, slapping zero trust on top of a product doesn't make it zero trust and it doesn't make it any different. So just a bit of an apology to my marketeers on the call who have jumped on zero trust as a word. Often when I talk to execs, they come with the opinion that zero trust is a bit of a buzzword. I think in some ways it kind of is because of what it's become, but it's also not. Hopefully at the end of this talk, I may have changed a few minds. And on that, zero trust is actually a strategy. It isn't a product. So you've got to assess the product's capability for your zero trust strategy, not necessarily its branding. So I'm going to give a keynote speech to introduce the concepts here today. I'll talk about how security has evolved through recent history, which is our careers for those on this call. And then I'll talk about what we can do to address the challenges. I found this format to be pretty helpful. After that, there'll be a Q&A section, so please ask me whatever question you want. It will take me 5 or 10 seconds after I finish speaking to read the questions and get to it, but I will get to it. Similarly, if there is something you're burning to ask me and I don't manage to ask it on the call, please add me on LinkedIn and just ask me there. That's completely fine. So, where to begin? We used to architect networks fundamentally differently, as they were very focused on the concept of a hard outer shell. Basically, you had the internet, then you had a perimeter firewall, then you had web servers, app servers, you had an internal firewall, then you had back-end application servers, database servers, and all sorts of other things. And this worked for a while because no computer could physically connect to the network unless you gave them a cable to plug it in. So they had to be in the room. And if you were on this network, you were trusted. You were inherently trusted. You can do whatever you want. And that made sense at that point in time. But all it would have taken would have been one bad actor. So when you think about this from a government, a military, or an espionage, a spying perspective, for a long time, those sorts of people were very focused on getting past receptionists so that they could physically plug into the networks. You can imagine how they might have done that. I know this because a couple of people at Okta used to have those jobs in different lives. So this all got a hell of a lot easier when Wi-Fi was created, as you didn't have to get into the building anymore. You were able to just park outside and access through a poorly configured Wi-Fi, which is very, very funny. I remember working personally for a defense company, the sort of defense firm that has quite a successful cybersecurity business. We had to physically plug in because there was no Wi-Fi. They had adopted the concept of a hard outer shell. That was their way of perceiving the world. But to make the point that I'm trying to make in slightly more of a fun way, I was once on site, and when I say on site, I mean like think of a large industrial campus, lots and lots of different things going on with people. And I was gaining access in a very mundane way. It was guys, can we go on mute, please? Thank you. Am I still on, Vinny? Hello.
Hey Max, yeah, you're still there. Can you do a share screen as well, Max, and hopefully we'll be able to see your video then?
Yeah, okay. For whatever reason, the video's just clicked off, so I think we're having a couple of tech difficulties here. Someone's changed the configuration or something. I can probably just pop up a webcam and mirror it if that would be a helpful thing to do. Bit of a strange one. Yeah, so I don't think I'm gonna be able to do that either because this app is using it's using the webcam. So I'll just crack on and we'll figure it out. So to illustrate my point in a more mundane way, like I was saying, I was accessing a large industrial campus. I was gaining access with a plastic ID card with a worn out photo. So no security chip, no RFID, no QR code, nothing like that. And it was just a visual check, not even a turnstile. And I was going to a warehouse because I was working on a deployed energy project. We were dropping generators into refugee camps was the project we were working on. How could we drop them out of planes and ruggedize them so they would land well? And someone had dropped down a container, it's a pallet actually, in front of my door. So I went to the adjacent warehouse as I knew that there was a walkway between the two. So I knocked on the door and I was let in. I thought that was strange. I guess by virtue of being on the campus, that was fine. And I looked around and I saw 5 houses, sort of like street houses, built side by side, windows, front gardens. Why would they have been built inside a warehouse? It's very puzzling. And then I remembered a rumor that I'd heard that there was a security services bug training facility here. So you would train the agents to covertly surveil or covertly break into houses and plant equipment. I realized that it was a fairly good chance I was standing in that. Now, let's take a second and just realize I should definitely not have been in that room. A front gate level of security was not enough. No one had verified that I specifically needed access to this thing. My identity hadn't been checked. And if it had, it would have been just an employee ID card. So it's the same entry credential. It's not secure. And there's no concept of a least privilege principle. Once I was inside the area, I could go wherever I wanted. The analogy is not unlike having a simple credential of a username and password to access a network. Once you're in, you're in. And that's the same one you've used 200 times to log onto a Wi-Fi at a hotel or a coffee shop. So you can almost follow the logic that by extension, the coffee shop's security against hackers is now in question as it somewhat affects your business security. If they get compromised, your first name dot last name, that's your username, your password, because you've used the same one everywhere, perhaps your home address or even your telephone number are out there. And it's all right for buying up data troves and mining them for password spraying style attacks, or even social engineering, which is much harder to combat. And once you're in with those credentials, you can go places you don't need to go. There are no policies currently around what you should be able to do based on who you are. So back in that world, back in those days, it was all quite simple because all you had was an app sitting on top of a server. But then a big change came about. It was the cloud, Salesforce, O365, Box, Slack, Zoom, G Suite, whatever you're using. And they took that core confidential, sensitive data and moved it outside of your firewall. If we'd said 20 years ago that core strategic infrastructure, your documents, your sales data, all of this would be outside of your network and outside of your control, no one would have believed us. We would have been laughed at. I think the great reason for this change is the acceptance that other people can do things better than us. And then another big change happened, another movement in the market. The iPhone came around. It showed the world that should we say the smartphone, but the iPhone is really the one I'm talking about. It showed the world that technology can be easy, attractive. It can be the thing you actually want to use. By way of example, how many times today have the people on this call pulled out their phone without having a notification just to look at sports, stocks, maybe to do some e-commerce, these things? Technology has become an integral part of our lives. Back in 2007, BlackBerry was the #1 device on the market with 96% market share. Then the iPhone put out a phone, then Apple put out a phone with no buttons at all. Technically it has one, or it had one, but let's not worry about that. So technology became easier. And that change meant that very recently BlackBerry was sold in bankruptcy. So I think the point I'm trying to make here is that if we're not making things easier and faster to use, we'll fall behind. But when we consider the iPhone, it's also worth noting the things it can't do. Its battery, its screen, its processing power were all limited. And the only way you can improve these is by actually buying a new phone. So a new, the new Galaxy or Samsung or whatever that gets released every year, you have to actually buy a new phone to get a better equipment. Your phone isn't suitable for doing a lot of stuff, but it can connect to something much bigger using the API economy and run complex tasks in the back end in the effectively unlimited cloud with unlimited processing, unlimited storage, and unlimited battery. So if you think about something like using Google Maps or Apple Maps or Waze, something like routing you from A to B is mathematically very intensive. So doing it on your phone would drain your battery because of the processor load. So instead, we run it in the cloud. We've moved the workload from our endpoint devices to the servers in the cloud. So now we have APIs running on servers powering things with applications on top and devices on top of that. And instead of the cloud simplifying things, we've actually made them more complex. There are now 4 layers we need to protect. And that actually leaves out the actor as a layer who is doing something, some good, some bad. So what we really have is apps and APIs consumed by devices and by users that we don't trust. They're built by developers that we don't always trust, hosted on systems we don't trust, run by other departments that we don't necessarily trust, run on servers that we don't control, but we still need to get the job done. When your app is hacked and someone downloads millions of records, and take the Equifax hack for an example, they don't go to the developers, they go to the group of IT leaders, the people who are listening in on this call. We hold the responsibility. We have to acknowledge that the perimeter is gone and we can't get it back. And it's actually been gone for a long time, but we don't like to admit it. It would force us to really have to think about the way in which we do things. That is, unfortunately, the world in which we live in. You've got employees, customers, partners, contractors. They all start to look very similar. There's not a cookie cutter or a boilerplate set of rules or approach that you could apply to these groups. So it all comes down to trust. How do you think about it? How do you figure it out? How do you apply it, revoke it, measure it? How do you operationalize trust as a concept? The consequences of getting this wrong are numerous, but doing it right has real benefits. So on my story through time, we've kind of arrived at the present day, and it's a bit of a bleak point, but what can we do? Well, it turns out there are 4 pillars, 4 points, 4 bits of strategy to consider in terms of how we can adopt to this new world. The first is context and its relation to security. So context is key. Who's trying to do what and when? When you authenticate into a system, you've got a ton of context. Credentials, so that's the username and the password. Past years of behavior, third-party intelligence, the device, the physical network, the geolocation. Most people just throw this all away and use the credential, the username and password, which is only one of the bits of context, because passwords can never be compromised, and all of our usernames aren't first name dot last name. Some more advanced thinkers apply some context. Hopefully some of the people on this call are applying this type of context. On or off network. That's how a lot of people do it right now. It's good. You can go a lot further. So when you prompt for multi-factor authentication, and for those who aren't familiar with MFA or multi-factor authentication, it's those annoying texts you probably get to scribe across a number to access something. They're great. A lot of friction. I'll talk about that a bit later. But if you've ever heard of the Superman rule, say you are in a state, I know that people are listening in from a couple of different countries. So say you're in the UAE or wherever right now, you can't log in and authenticate in from there, and then within 15 minutes, log on or authenticate in from North Korea or America, because you physically couldn't have made that distance. So we would lock off that, for example. If we focus on device identity, is this a device we've seen before? Is it recognized? Is it part of our mobile device management, MDM? If you always connect with the same computer and the same phone, that's interesting to know. If you've registered with this device, that's valuable to know. And as an authentication from those specific devices should have different degrees of trust, perhaps a little bit more. Is this the device they enrolled with for MFA factors? Is it part of the managed devices? Just asking these questions improves security. And within devices, you can go a step further. You can look at the application layer. If we fingerprint the application, is this the app we released to the App Store, or is it something else? If you're a bank, if I was a bank, for example, you'd want to know your customers are using your app and not something else to connect to your APIs. And if we look at the user's identity, there are certain transactions that are inherently high risk. Take enrollment, for example. That's inherently high risk because if I enroll as you and I enroll my devices for MFA, I have that identity. I am that person. I can attack your account. I can reset your password. I can even turn off your MFA factors. That's a pretty good attack. So in that scenario, you might need to force an MFA challenge beforehand as part of the log on or the registration flow. You might even just want to lock off new devices from doing these types of things and only restrict that to devices you've seen before or trusted devices. Most users only change their password when it expires. So in the kind of internal IT world, that's when you've got like a 3-month rotating password and someone has to go from their password being maxfawn1 and they then change it to maxfawn2, because that is what every single user is doing, by the way. If we take something like a password reset, as an identity provider, and that's what Okta is in these scenarios, we know that a password reset has happened. We can send signals downstream, for example, to revoke all active sessions in things like Salesforce. If you changed your password because you got an email from Marriott Hotel Group saying that you're part of the breach that they had, was it last year? You might want to quickly change your passwords because you realize your Marriott password and your Marriott username are the same as your work username, or the username for a B2C portal that you're accessing. You can change your password, but if your sessions aren't revoked, anyone that's logged in as you still has access. You're still breached. It may not be breached from the identity provider's point of view, but it definitely is from yours. This is just one directional from the identity provider's perspective. But what happens when we think about this from the angle of apps? Your apps know behaviorally what you do or don't do. If an HR guy accesses payroll at 10 a.m. on a weekday, that's fine. But if the same guy starts giving raises to people at 2 a.m. from Vegas or Macau, that's not fine. There could be a problem there. They might have authenticated through your identity provider successfully. And we don't know what's going on in the app, and we shouldn't, because that's not what we're here to do. We're not within app monitoring. That would be a place we don't want to go. But the app can notify us that something's wrong and force additional factors, notify security teams. The security teams might want to check on this, DevSecOps. It mitigates or pauses a breach in action. If we're told there's a chance of a breach, we can kill all sessions. That's really powerful. Now let's think about this from a customer, B2C, B2B, SIAM. Our industry calls this thing different things. I mean, everyone that isn't an internal contracted employee. You might want to attack at registration. Something like setting a username and password, setting a factor, these are the times to go for it. But everything a user does, a bot can do too. We know we're not experts in bot activity or in tracking every hacker in the world. You'd need a company to track bot networks and their usage, and there are. We have partners that do this, and we can pull in third-party data to enrich our context. It might seem like human behavior to us, but a third party can signal to us it's likely a bot, and we can stop it in action. And if we don't let you register in the first place, you can't get access to anything else. I think on this point, part of this access piece, adoption, your users' adoption is very important. Whilst in B2E, so to your own employees, you can kind of get away with giving your employees a bad experience, as some of their working lives have been with legacy technology. Has anyone ever tried pulling an engineering drawing off an ERP, for an example? That's the sort of thing I'm talking about. But younger ones grew up with iPhones, Galaxy, whatever, Samsung. When we think about our customers, much like our younger employees, putting friction in front of them makes them end their sessions. They don't complete whatever they came to do in your portal, or they don't buy the thing on the e-commerce website. Contextual security is fantastic for addressing this. I bet the people that MFA on this call for their employees, I bet they MFA their employees every time they log on. But with the context of, if it's in the office, therefore it's on our IP, and if it's on our managed devices and they're accessing a system, an app that doesn't need a high level of security, I bet that if you applied that level of context, you wouldn't need to MFA as much. That makes them much happier employees. And when you think about that to your customers, your B2C, maybe you need to apply that layer of security because someone is updating payment details. It's possible to do it within your app, or addresses or whatnot, personal data. You could not MFA them when they log on as they're just browsing. And maybe you can recognize the device and the IP address. It's the same one they've logged on for the last 3 times. But when they move to a more sensitive area, like personal data, like, changing shipping addresses, things like that, you could do what's called a step-up authentication. And then you would MFA at that point in time once they're committed to that transaction. So it's the idea of only MFAing when you have to avoid getting in the way. So the first pillar was context and security. The second pillar is having an open platform. The better we can inform you and create the context that I've just spoken about, the better it will be. But it requires one more step, an open platform. So I said I wouldn't talk about Okta too much or at all. I have to briefly in this section because it informs it. Okta's approach to the open platform pillar is the identity engine. When Okta was founded 10 years ago or so, it was built on a lot of assumptions and focused around workforce and employee use cases. But since then, we've expanded out into all sorts of things like customers, B2B, B2C, server access, all these types of things. So some of the old assumptions didn't necessarily make sense to the new world. The identity engine is the ability to override things in our product. You have the defaults, and you can turn these off now. One of the core things that we think about and we say is that there's an acknowledgement. We don't know everything. Our job is to understand trends, protocols, practices, security, not to understand your business inside and out. That's your job. The identity engine is the ability to take that understanding of your business and plug it into us. We don't have to figure it all out. We just have to let you do it. So it's kind of self-interested, that better security for you and less work for us, right? So with all this context and an open platform, you could use things like hooks, if anyone's ever heard of these, event hooks. Something happens within your app or your network, a user logging in, registering, logging out. We make a webhook out and say there's a context of the event, some context of the event that just happened, and you might decide what you want to do with that context. You could start actions or processing. You could have a logic function. You could have further actions. So with something like an inline hook, you can redirect Okta and tell Okta to do something different than before. If you detect something that's a bot, you can prevent it from logging in, even if it's already registered. That glue lets you connect things together. Think about as part of a registration flow in a B2C portal. You might want to hook out to a credit checking agency to provide a layer of identity proofing to that registration. I don't know if people have experienced it on this call, but often in the UK, when you sign up to a credit card or a banking app or whatever, it asks you a series of questions like, who is your mortgage with? Name, the 3 credit cards you own, for example, and it checks them against a credit checking agency. That is what I'm talking about, because you can't make that stuff up. The level of knowledge it requires someone is too high. So the third pillar, so you have your open platform, you have your context. The third pillar is actually everything being connected. There's no one vendor, technology, or app stack that ties the whole thing together, regardless of what Microsoft might say. There's no singular way of doing it. The apps must talk better. They need to do better. We accomplish this with open standards and protocols. That's dragging your legacy apps into the modern world with modern protocols. On this subject of interconnection, we, the identity provider, normally know things before they've happened. We know hacking groups have released a data set, for example. We can then go ahead and take additional actions like forcing password reset or revoking tokens and sessions. We know that you're high risk right now because of this thing that's happened that you don't know about. But that doesn't mean you need to stay high risk. You can earn that trust back by accomplishing a password reset, by accomplishing many different things. So lastly, it's the network effect. And this is probably my favorite one. More apps communicating more effectively. And more networks communicating more effectively. So I've spoken about our network, our devices, but how many attacks actually come through someone else, like a subcontractor? So I'm not sure, we don't have it in the UK. I'm not sure if it's over in the UAE, but Target in the United States is a great example of what I'm talking about. They had a subcontractor monitoring their HVAC or their air conditioning systems in their shops all over America, their retail outlets. They're like a very large retailer that is in many American malls. It's a big deal over there. So some random vendor didn't secure their system well enough, but their system had access to Target's corporate IT system because, Target had the same idea of security, a hard outer perimeter. Right? If you're in it, you're in it. If you're out, you're out. Well, this vendor was in, but their security was bad. So attackers breached the vendor. they got access to Target's IT, and they started pulling down customer records and payment details. We need to think about attacker behavior, not just our own network and security. Odds are, when an attacker comes along, they didn't come straight to us. They went to a competitor, a customer, another vendor, a supplier. With this network effect of knowledge, what we need to do is connect everything and have an internet scale neighborhood watch. So a great level of this is actually in your geography specifically. So I have to be very careful how I phrase this, because whilst it is public and you could go and Google it if you were watching Okta's conference videos, I don't know how widely it's known. So a state was attacking the UAE's critical infrastructure. It was a nation state attack against another nation state. To my knowledge, all the critical infrastructure that was attacked went down, aside from the airport, as that airport was using Okta. We, as part of monitoring, the entire world, because everything is connected to us, were noticing that nation state that was initiating the attacks was doing this. We'd spotted them hacking other people at this specific point in time. So we locked it out. It raises the interesting point that when you do a deployment of a more traditional on-premise software, because each deployment is entirely custom and siloed, you don't have the ability to do what I'm talking about now. So this network effect. And by the way, for a little bit of context on those attacks, in case you're wondering, why didn't that affect me? I don't know about that. This was on the stroke of midnight at New Year's Eve. So the question, firstly, you guys weren't in the office, but secondly, the question I would ask is, were your security teams in the office monitoring traffic at that point in time? Were you running a skeleton crew? Just one person drew the unlucky straw of having to work that night. Would they have been able to stop this? So we can adapt and change our security posture because an organization that is over there or over here or a peer of ours is under attack. If something is under attack by a specific means, we can adapt. We can be proactive about security instead of reactive, which is what most security is. We can protect our users before the threat has even come, because there is always a threat. So thanks for listening. I don't know what's going on with the video. Sorry about that. Right now, I'm just going to quickly scan down some questions. Please ask questions as I'm done talking. Let me just have a second and look through what we've got.
Thanks to all the attendees for joining the session. We will be sending you an email right after the session with the recording of the session as well, so that you can always get back to us with any queries you have. Thanks again, and I hope all of you have a great evening ahead.